Quicker than the actual design of spacetime itself, it has the ability to keep up with its consciousness of it. Subsequently, it will gradually dismantle this thought, filling me with a feeling of disquiet. As of now, our night sky is quickly changing, and inside the next few decades, perhaps sooner, it could turn out to be totally unrecognizable. Specialists, including deGrasse Tyson, are sounding the caution, perceiving the unavoidable changes welcomed on by the moving of Polaris. The foundational ground behind this change is shockingly surprising. Polaris, regularly known as the North Star, has been a dependable element overhead for a long time, filling in as a fundamental perspective for cosmologists, pilots, and stargazers alike. However, this could before long be modified, impacting the manner in which we see the sky and how we concentrate on the universe. We should inspect what this change could mean for us. For a long time, Polaris has been a guiding light for mariners and cosmologists, remaining immovably situated overhead. Its reliable presence has been essential for navigation, yet this solidity may before long be disturbed. A paper from the regarded Royal Astronomical Society, published in September 2023, raised concerns about the fate of this divine marker. Polaris is entering a tempestuous stage, one where it might actually detonate, vanishing from sight forever and modifying the sky as we know it. Before considering the possible outcomes of this event, we should look further into the qualities of the actual star. Polaris is unmistakable due to its closeness to the heavenly North Pole, situated directly over Earth's northernmost point. It appears to be practically unmoving overhead. It dwells in the Ursa Major constellation, which is commonly known as the Big Dipper. Polaris shines with a moderate brilliance, resembling a yellow-white very giant star that is much bigger and brighter than our own Sunday. However, Polaris isn't simply a solitary star. It is part of a complicated triple star system, comprising of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational forces between these stars influence their orbits and behaviors, and interruptions in their interactions could cause shifts in their brilliance or pulsation patterns. However, the exact nature of these forces is still not fully understood. Polaris is located around 323 light-years from Earth, meaning the light we currently see from it began its journey quite a while ago. If Polaris were to detonate, we wouldn't see the effects for over 300 years. It's even possible that Polaris has already detonated, but we have yet to observe it. Over the course of time, the North Star has held significant cultural, navigational, and symbolic importance. Its constant position has made it a valuable guide for ancient mariners navigating across oceans and lands. Symbolically, Polaris has represented stability and direction, staying unaltered in the constantly moving sky. For stargazers, Polaris has been a pivotal reference point in the study of celestial movements and variable stars. As a Cepheid variable star, its occasional changes in brilliance have provided crucial insights into the properties of stars and the behavior of variable stars. This characteristic has also been key in measuring astronomical distances and aligning scientific instruments, as its pulsations follow a predicted cadence, making its behavior easier to forecast. As of late, however, Polaris has begun to show signs of straying from its normal behavior. This inconsistency in its pulsation cycle has fascinated cosmologists, prompting further investigation into the cause of these unexpected changes. Instead of sticking to its usual pattern, Polaris has started to display irregular dimming, which has led to concerns that the star may be approaching the end of its life cycle. This behavior is consistent with what is found in stars that are nearing their final stages. The slow expansion in the pulsation period of Polaris, when consistent, has been traced back to interactions within its star system. There has been an annual increase of around 4.5 seconds in the pulsation period. While this might seem insignificant, it carries important implications. Some astronomers suggest that gravitational forces between the stars in the Polaris system could be driving these changes in its atmospheric conditions, directly affecting its pulsation patterns. Others are more concerned that Polaris is entering a critical stage that could lead to an explosion. The similarities between the behavior of Polaris and that of Scarab, a prominent star in the Orion constellation, are striking. Both stars have shown complex variations in brightness, raising concerns that they might be approaching a dramatic end, potentially signaling the end of their stable phases and the onset of more extreme processes such as a supernova. If Polaris were to explode, it would mark the conclusion of an era for astronomers and stargazers who have relied on its steady light for centuries. The loss of such a critical reference point in the sky would not only have navigational consequences, but also challenge our understanding of stellar evolution and the life cycle of stars. The potential explosion of Polaris raises significant scientific questions. What will this mean for the local stellar environment? Could the explosion trigger other cosmic events in the surrounding regions, such as the formation of new stars or the disruption of existing celestial bodies? The effects on Earth would not be immediate, but scientists are already working to understand the implications of such an event, both in the short and long term. As we continue to observe Polaris, we may soon have a front-row seat to one of the most profound transformations in the night sky. Whether it will gradually fade from view or end in a dramatic explosion, the fate of this iconic star serves as a reminder of the dynamic and ever-changing nature of the universe. The study of Polaris and similar stars will continue to provide valuable insights into the forces that shape our cosmos, reminding us that the sky, much like the universe itself, is constantly in motion. Blast stars toward the finish of their life cycles frequently display such inconsistencies before their destruction. NASA has communicated greater concern about bug dews, yet formal consideration has yet to be fully coordinated toward Polaris. As a seeded variable star approaches the finish of its life, it goes through a few phases, including the red giant stage, and ultimately a cosmic explosion blast. Given the unpredictable throbs saw in Polaris, researchers predict that it has entered the period of helium depletion, which is common for giant stars approaching their end. These anomalies line up with patterns found in stars approaching the finish of their life cycles. However, strong evidence of a looming cosmic explosion is still uncertain, and cosmologists are continuing to track these peculiarities to better understand the destiny of Polaris. Should Polaris go through a cosmic explosion blast, it would probably be a grand event overhead, potentially dominating the moon and staying visible for days, weeks, or even months. Its splendor could dramatically alter our perspective on key heavenly bodies like the huge Scoop or Ursa Major, in which Polaris plays a pivotal role. Luckily, Earth would likely remain safe, whether or not Polaris detonates, because of its size and distance from us. While the blast of Polaris probably won't be as visually marvelous as bug juices, it may still be apparent to the unaided eye for an extended period, eclipsing nearby stars. This would undoubtedly draw the attention of astronomers and observatories, generating worldwide interest both in the academic community and among stargazers. However, the effect on Earth's environment or atmosphere would be less significant compared to a cosmic explosion closer to our planet. But what will happen to Polaris itself? What is its fate after a potential cosmic explosion blast? First, it's important to note that while enormous stars commonly end their lives in a cosmic explosion, this isn't likely for Polaris. When a huge star undergoes a cosmic explosion, its core collapses, setting off a violent shockwave that causes the star to deteriorate. However, Polaris isn't massive enough to undergo such a violent event. Rather, once it depletes its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition won't lead to a cosmic explosion, but rather a quieter end, as Polaris evolves into a small, incredibly dense celestial remnant. A white dwarf is the compact core of a low to medium-mass star that has exhausted its nuclear fuel. This remnant, although roughly the size of Earth, will still have the mass of the Sun. Once this process occurs, we will no longer observe Polaris in the way we know it. By studying the effects of a potential Polaris blast and comparing them with those of actual cosmic explosion events, we can gain valuable insights into the evolution of stars and their ultimate fates. For instance, cosmic explosion events like SN 1987A, SN 2011FA, and SN 2014J have provided significant information that helps us understand what could happen to Polaris in the future. For example, SN 1354 resulted in the formation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various frequencies, providing astronomers with a rich field of study. Additionally, SN 1987A, observed in the Large Magellanic Cloud, offered crucial insights into nucleosynthesis and the mechanics of cosmic explosion remnants, such as cloud development and the release of high-energy radiation. These discoveries can help us better understand the unique characteristics of Polaris. The development of nebulae like the Crab Nebula occurs when material expelled during a cosmic explosion interacts with surrounding interstellar gas and dust, enriching the gas with heavier elements and contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying the differences in the composition and speed of ejected material between Polaris potential blast and other observed cosmic explosion events. By analyzing light curves, spectra, and remnants from these events, they can make predictions about the likely explosion of Polaris. This research will help determine whether Polaris explosion could lead to nebula formation or affect celestial distributions in significant ways. Another crucial area of study involves the pulsational fluctuation of stars nearing the end of their life cycles. By comparing Polaris with other cosmic explosion progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind stellar explosions. The variation in pulsations in stars nearing death might indicate internal instability or an impending catastrophic event, offering valuable clues about the processes that lead to cosmic explosion events. Despite detailed observations and research, scientists are still puzzled by the anomalies in Polaris behavior. Understanding the causes behind these oddities is crucial for advancing our knowledge of stellar evolution. The investigation into the dynamics causing Polaris' unpredictable pulsations requires collaboration across various scientific disciplines and the development of advanced models and observational techniques. The potential loss of Polaris as a celestial reference point raises important questions for galactic exploration. Ground-based telescopes and measurements of stellar distances would require recalibration, which would affect the accuracy of celestial measurements. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers, emphasizing the importance of this event. The mysterious behavior of Polaris highlights the need for further investigations and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful solutions to determine the star's future.